In John's spare time, he enjoys benchmarking, working more hours, right on, lacking sleep, self-proclaimed wine connoisseur, we'll be talking later, and participates in extreme fitness activities. I could probably use some of that too. I'm really looking forward to, having video of this talk, because I think, having seen the slides, I think this is going to be really useful for the community. So thank you.
Thank you.
Ladies and gentlemen, John Fragalla.
Well, thanks for having me. The goal of this presentation was to discuss configuration and tuning around a hybrid configuration of non-routed and routed clients, where you're trying to extend the basic Lustre file system that's based on IB to an Ethernet set of clients. And what I want to go is walk through the configurations and some of the caveats that I've noticed through the configuration of trying to do this routed and non-routed configuration with LNET, and then also providing resiliency to demonstrate that when a router fails or an OST fails or any type of functionality of failover occurs or router failure, to have the I/O continue. And that's the goal of this presentation. So the agenda is to provide a configuration goal of what the initial setup is, provide high-level benchmark setup, and then walk through about 4 different phases of the LNET configuration that I went through to finalize the absolute configuration. And obviously we could go through much more iterations, but we're at the point where I was happy with where we ended up in terms of performance and resiliency testing, and then give you some insight of testing with 4 meg I/O RPCs compared to 1 meg I/O, and in summary and references. So the configuration goal is I had a InfiniBand-based Lustre file system. I have InfiniBand-based clients mounting directly the file system. Majority of the I/O and majority of the performance will be on the InfiniBand clients. There was also a need to extend data access through LNET routers to Ethernet-based clients for providing additional functionality and I/O. But the majority of the priority of the applications will run on IB, but this wanted to extend the addition of data access to Ethernet clients. And they wanted some way of doing that other than using a lower level protocol like NFS, for example. So you leverage basically Lustre functionality to do that. And whatever happens on the routed side, so if you had a router failure, or if you had clients that had disruption of access, the majority and the priority of performance and functionality should not disturb the InfiniBand-based clients. And that was the goal of this configuration and the walkthrough. So the benchmark setup, I know it's a little bit of an eye chart. Basically, just to reiterate, my basic Lustre NIDs were all on O2IB0 for the MGS and MDS nodes. I had 4 OSS nodes leveraging Seagate's 4 OSTs. Everything was configured in HA pairs. So the MDS, MGS were in 2 servers on HA pairs. Also OS servers were also in HA pairs. For this specific benchmark setup, I had 16 IB clients. And then I also configured 4 Ethernet routed clients and then 4 Ethernet clients. And they were all running 10 gig interfaces. And then this gives you an example of the LNET routers, the IP addressing of O2IB and at TCP for those configurations. So on the server side that I tested on the Seagate implementation of Lustre 2.1 and Lustre 2.5. I also tested on LNET routed and Ethernet and InfiniBand clients that I had a consistent client version across routed and non-routed clients and LNET routers. So on the Seagate version 2.1, I tested 189, 2.1, and 2.4.3. On the Seagate version 2.5.1, I tested 2.4.3 and 2.5.1. As you can see, as we progress through this presentation, all the configuration applied to all different scenarios of client configurations and server side, and all performance was relatively the same. So, but I just wanted to give an example that I did some exhaustive testing across multiple clients to see what was the best setup and configuration. And majority of them, in terms of just the performance, all resulted the same performance. So the client options that I decided to do initially With disable checksums, I set max RPCs in flight to 256, max 30MBs to 256, and I decided for the initial testing to only do 1 meg IO RPCs. And then this is the mount command that I had, consistent across all clients. Routed and non-routed clients had this mount option as well. So let's go through the initial LNET routing configuration that I put together across the server side, the routed clients, and then the IB clients that were not routed. And basically the way that I came up for this initial configuration was basically leveraging reference materials and then applying that to a test. So the reference materials is what indicates in red and bold. Bold is what's consistent across all clients, and red is what's different. So on the server side, I've modified two files, the etc modpro d lnet.conf and the etc lustre routes file. So basically it's a reference pointer to the LNET routes to say these I have my 4 routers. And I leveraged initially the KO2IB LND parameters initially for the InfiniBand side, and I did the check routers before use, live router checks. Most of this stuff is all documented, so this is best practices what to do on the server side. And I decided to leverage the option LNET networks on the server side and on the client side, and did not leverage the IP2 nets other than on the LNET router side. On the LNET router configuration, the highlighted in red were what's specifically to the LNET routing configuration. So it leveraged the IP2 nets configurations as saying that these are the routed configurations from O2IB0 to TCP. And then these are the routes that I have. They're basically specifying the 4 router configurations. And then on the routed Ethernet clients, the main difference is the LNET networks because it's a Ethernet interface. I had to leverage TCP and Ethernet 20 as my device. And then I also leveraged the routes command as well. And then the other thing as well I noticed is that you notice that there's a separate file for KO2IB LND.conf file. The one thing I noticed when I included these 3 options in the standard LNET.conf file, there was actually degradation in performance on all clients when I included this in the master LNET.conf file. So what I did was I removed the KO2IB LND parameters and created its own file under etc modprobe.t, and performance came back to expected results. So I thought that was an interesting thing to point out, and that's why I created a separate file for that in the etc modprobe.t.d configuration. And then this is a little bit different that I initially thought, for example, because the IB clients were not routed, I figured that in the LNET.conf file, I did not need to include all the standard LNET routing configuration parameters because these are mounting the file system directly on the IB clients. So the only options I had in the LNET.conf file was the networks option, basically leveraging the LNET and the interface using. And then I also had to include the KO2IB LND.conf file as well because you cannot mount the file system. If the server side has these options, the client side also needs to have these options. So it gives you a high level where I initially started my LNET configuration for this hybrid setup. So I did find out what was interesting was KO2IB LND for this specific benchmark was not absolutely needed in terms of performance or any additional functionality. And it also provides a bit more complexity in your overall LNET design when including the KO2IB LND configurations. For example, if you had a separate file system, so let's say you have 2 separate file systems that are IB based. One is in this configuration where you have a routed configuration Ethernet. The other base InfiniBand file system is a standard file system, but you're leveraging the same clients to mount both file systems. If you leverage KO2IB LND on one file system and the clients have the same option, the non-routed standard InfiniBand second file system also needs to include these options on the server side to mount the file system on the same network, or on the same client, I should say. So I decided to, for my testing, to remove, moving forward, the KO2IB LND configuration from this particular setup because performance and resiliency didn't play a big factor into that. The other thing I thought was interesting, because I had the inconsistencies of different LNET.conf configurations between the InfiniBand clients and the Ethernet clients, when I ran my simulated testing via IOR where I just mounted the file system on IB, but ran IOR over the Ethernet clients that are routed. I did see some interesting I/O characteristics when there was the LNET configurations that are inconsistent across the client side. What happened was when you ran IOR in a write and read mode under the same command, the write's complete, but the read phase never started. I/O just hung for IOR. So I could not get the read phase to start, which then pointed me out to, let's retest the IOR configuration. And even though my IB clients are not routed, let's apply the same routed configuration to the IB client and retest the configuration. So the next phase of testing I did was remove KO2IB LND everywhere in my configuration and provide a consistent LNET configuration across IB and Ethernet clients and retest. So when I did that, that solved the issue that I saw with IOR where the read phase would not start. And then this configuration, the write phase completed, the read phase started and completed with no issue. So I thought that was an interesting fact to look at. Furthermore, I wanted to test resiliency testing with just on the router side. So the IB side was still mounted, no I/O was running, and I wanted just to run IOR and simulate a router failure. And this is with 1 meg RPCs. So during router failure, during write phase, when I killed the router, and I basically unloaded the Lustre modules on the router side. That's how I basically killed the routers. And there was a interesting characteristics when I was monitoring I/O on terms of performance tools. So when I kill the router, there's 3 different LNET check router intervals that we look at. The dead router check interval, the live router check interval, and the router ping timeout. Because I was doing standard round robin configuration for the Ethernet side, when I killed the router, all the I/O halted for roughly 60 seconds. So you see a pause in I/O 60 seconds until its peers identify that the router is actually down. So you cat the procsys network LNET or catsys LNET peers file. You see an up, and then over time it changes to down for that one router. All the threads that were not leveraging the router that failed resumed within about 60 to 120 seconds. The threads that were writing to the router that was failed resumed I/O roughly 2 to 4 minutes after that in this configuration. I did the same thing on the read phase where I recovered the router, so now I have 4 routers still operational, and during the read phase I also killed a router during that. Different characteristics on the read phase. The read phase paused consistently always at 60 seconds and quickly resumed reads. And then there was never really a 2 to 4 minute pause. There was really only a 60 second pause in the read phase during a router failure before reads resumed on the OSTs. The other test that I wanted to do even further was, okay, I could now survive a router failure. I wanted to now do a full resiliency testing with both I/O running on IB, I/O running on the Ethernet clients, and during the write and read phase, I want to simulate multiple failures at any given time. So I simulated a router failure, I simulated an MDT failover, and I simulated an OST failure within about a minute apart of everything going on. And the purpose of this was not performance, but the purpose was to see resiliency and IOR completion. And over time, it did all survive. IOR did continue, and IOR did complete with an IOR job. So I was pretty happy with that resiliency testing. So the first phase, I was happy with where I was at in terms of resiliency, and I wanted to see how I could optimize performance on the configuration. So the next thing I wanted to do is look at weighted routes versus comparing to round robin routes. So the thing is, the only thing we needed to change on the Ethernet routed configuration, I wanted to look at weighted routes. And the way weighted routes is that it's basically like leveraging an NFS mount point. You have your primary server, your secondary server, and so on and so forth. So on each client, I had a different primary router to point to. And this gives you the color scheme, how I configured each of the clients in this scheme. But everything else changed the same. And then when you look at the cat procsys LNET peers, you can see that my first client used router 1, my second client used router 2, my third client used router 3, and my fourth client used router 4. There was no round robin against any of that. It was basically isolating a set of clients to a set of routers. The caveat thing is you see the performance numbers at the bottom. My max write was roughly 1100 megabytes per second. And my max read was where I was expecting it to be, at 3200 megabytes per second. My writes were way lower than I expected. So I went back and retested peak performance numbers of the standard round robin configuration. You can see now the difference in the CAT, PROC, LNET peers is that all clients are using all routers simultaneously. But now the performance is dramatically much better on writes, about a 3x performance increase. But the benefit of what I see with weighted routing was on the resiliency of simulating router failure. When I simulated router failure with weighted routes, the only I/O that was affected was on the router that went down. All the other clients that had primary routes of routers that stayed up only had a 60-second pause so that the routers could identify where the router went down. Once it identifies the router went down and the peers notify the router is down, those I/Os resume within 60 seconds. Unlike the other side where it could take up to a few minutes to resume I/O. So with weighted routing, you have a more deterministic time to resume I/O versus round robin during router failure. But the 3x performance degradation with weighted routing, I think, outweighs the benefit of performance. But resiliency is a benefit that I saw with weighted routing versus round robin. And I hadn't tested this out, but one of the thoughts is if you had a larger set of routers with a larger set of routed clients, maybe a combination of routed round robin configuration might be a good happy medium for performance and failure resiliency in this configuration. The other thing I want to do now is how can I tune better Ethernet functionality, because there is an Ethernet play there. So now there's another module I can leverage, is the KSOC LND, which improves TCP connections. So this requires two different changes depending on the performance. Because the IB side is not an Ethernet-based Lustre file system, it is an IB-based file system, I decided for consistency to change the server side to leverage KSOC LND peer credits to 32. So this was a performance tuning that we've come up with at Seagate, that if you had a 40 gig back-end file system, 32 was a good happy medium. Because we're using IB, this options won't be picked up, but I decided to put it in there anyway for consistency across the LNET fabric. On the routed and non-routed side, I also provided a module called ksoclnd.conf file. So even though on the InfiniBand side, we're using IB clients, and we're not going to pick up the KSOC LND options, I included it anyway just based on my initial test of consistency across all configurations. And then on the Ethernet side and on the router side, I also provided this functionality. Now what I did notice a bit was a marginal increase in performance using the KSOC LND options for the Ethernet routed client side, about 100 megabyte per second on both reads and writes. The other thing that I also noticed was the failure time during a router failure and I/O resume. When I timed it during the wall clock time, it seemed to be responding better to quickly resume I/O with these options in place than without these options in place. So then I was pretty happy where I'm at with the Ethernet side, providing these tuning parameters. So then I decided to say this is part of my final configuration testing to use KSOC LND on the Ethernet side to just not provide additional performance on the Ethernet routed clients, but it saw a better behavior during router failure. So the next thing is 4 meg I/O testing. So this was the most interesting part of my presentation, and for the longest time I was going to come up here, and I'll confess this, I was going to come up here and say during router failure 4 meg I/Os just does not work. Because of the work that our Seagate Lustre development team had with our partner Cray during a certain testing of acceptance testing, we found the culprit of why it didn't work. So I wanted to go through the initial testing of what happens before the patch landed and then after the patch landed. So what changed was just the max pages per RPC went from 256 to 1024. So what happens during LNET routing when you change just that one client tuning from 256 to 1024 and simulate router failure without this patch in place, what happens to the file system is quite detrimental, not just to the routed side, but to the entire file system. When you have 4 meg IOs without any router failure, just let it run at peak performance, 4 meg IOs completes writes and reads no problems. As soon as you simulate a router failure with 4 meg IO in place on the Ethernet side, IO never resumes for those clients, any clients. So as soon as you simulate a router failure with 4 meg IO and you kill a router, you see on the performance tool, IO never resumes. If you wait long enough, like I did, I waited about an hour. I was really patient with this test. The file system starts reporting in a very unhealthy state. You get in a wedge part where you can't even stat the file system, do an LS, or do any type of functionality in this because of this, of the 4 meg IO cannot resume, and you have hung threads, and this is a bulk IO issue. For the longest time, I took it upon myself saying it has to be a configuration issue. It can't just be anything else. I went and looked at the MTU sizes on the Ethernet side. Is it the 1500? Is it a 9000? Or is it somewhere in between an MTU size because I'm doing 4 meg IO? Maybe I set it to 4096 for the MTU size. I looked at all the different timeout values. I looked at all the different modules, and we came to the conclusion that it was a 4 meg issue because as soon as I went back to Mac Pages RPCs from 1024 to 256, everything worked just fine. But we landed a new patch. It's you extract an LU6441, where it fixes this issue, and it's basically the multi-bulk I/O issue. And I actually got an extension from the committee to retest this patch, and this landed in one of our system updates, and it'll be landed up into the community. So we're providing this patch back up to the community. Again, LU6441, it's where it's tracked. And we put the 4 meg RPCs in flight with this new patch and basically simulated router failure and expected behavior resumed, IO resumed. And then I went even further and did full resiliency testing. MBD failure, OST failure, router failure, multiple router failures, router recoveries, read and write phase, and everything resumed as expected. So this patch has landed, and we're providing this back up to the community, and it's being tracked in the LU number as I mentioned. So in summary, I walked through where I had a great learning experience trying to figure out, not just trying to figure out how it works, but doing it in a resilient and reliable fashion to survive multiple failures. And the consistent LNET configuration was one point that I learned, and the KSOC LND to improve Ethernet connections for routed clients to an InfiniBand side, and the multi-bulk I/O patch also addresses the 4 meg I/O RPCs with LNET routing configurations. And lastly, the round robin provides much better performance, but weighted routes provide a more deterministic failover time during router failover. So it kind of references acknowledgments. So Seagate acknowledgement team, the Lustre development team at Seagate, and some of our colleagues, Bill Lowy, Rob Roy, Scott Milk, Carl Meritz, Nathan Ruttman, Chris Walker, Torben Kling-Peterson, Carlos Thomas, and Rex Neck, and all had a contribution to this work that we had here, and some of the online materials that I referenced during the course of my work. Thank you. Do we have time for questions?
Some of the numbers selection you have, like concurrent send of 63 and then peer credit of 126. I wonder how you came to that kind of a number. Is it from trial and error or some other?
That was, so are you talking about the KSOC LND numbers?
I'm not sure which part, but it was earlier.
Let's see. These values,
right
correct?
there.
Yeah, so the KO2IB LND parameters were leveraged off reference material that I have a pointer in the end of the presentation. But then these numbers, I basically, KO2IB LND, I did not leverage in my final configuration. Now the buffer credits were also based on documented reference materials that I read. I didn't honestly play with these values. I just leveraged them. But I did notice one thing when using large router buffers. If I did not use them or use them, there was an impact on read performance. So having these options, the large router buffers and small router buffers, did provide a positive impact on read performance. That's why I kept the values in. But it did not play with the certain values. I just saw a reference material that I have at the end of the presentation, and I leveraged that reference material.
I mean, one of the main reason I asked was I've never seen odd numbers on the default settings, so you may have some special reason to avoid the like deadlock condition or anything like that. But
It'd be good to do further investigation on that. Yeah.
okay. Thank you.
Anybody else? John, thanks a lot.
Thank you.